Okay, so today we're going to talk about arc length, and the following video will be on surface area. Both of these sections we're going to do pretty short. I'm probably going to make a 15 or 20-minute video on each. They're kind of a plug and chug into the formula type thing. So I just want to give you guys a little background on where this kind of idea came up with, or where we kind of came up with this idea in math. So what we're going to do is, let's say we have some function y equals f of x. I'm going to just draw a little triangle right here. This is supposed to be a straight line. Sorry, my hand did not draw a very straight line. Oh, it still didn't do it. Okay, so we have this little triangle, this little right triangle. And then what we're going to do is we're going to label this L for length, for our arc length. And then we're going to label this dx, and we're going to label this dy. Okay? So what this is basically saying is that this distance right here, we are naming the distance dx, and we are naming this distance here dy. Okay, so that's all I'm really saying. Now the thing is I know it's not exactly true. I know it's not true, but this, sorry about this, you guys, my screen won't close. Okay, so the thing is this little distance right here, this distance right here, oops. This distance right here is similar to this distance right here, okay? So what I'm trying to do is I'm trying to use this line of my right triangle to approximate the arc length of the actual curve y equals f of x. Now, I think you would agree it won't be right, but you could say, well, it's not right, but maybe it's a decent approximation. So what I'm going to do is I'm going to try to label that length. So I'm going to come over here and I'm going to say that length L. Okay, well, you know what? I'll write it in green since that is what we're using. That length L is going to be worth the square root of dx squared plus dy squared. Okay, and that's just the Pythagorean theorem, and then you square root both sides, right? A squared plus b squared equals c squared. I square root both sides, and that's what I would get. Now, if I wanted to, I could factor out the dx squared. Okay, so you might wonder why. So I could factor this out, dx squared, and let's see what that would leave behind. That would leave behind 1 plus dy over dx squared. Okay. Now, if you're, in Calc 1, if your teacher did not teach you this, this is definitely something you want to talk about. I use this all the time, where pretty much you can factor anything out you want. Well, I guess depending on what school you're taking this at, this is a Calc 1 video or a Calc 2 video, depending on what school you're at. So you should have learned that you can factor anything else you want. So I could take n squared plus n plus 1, and I could rewrite that as n squared times 1 plus 1 over n plus 1 over n squared. This is factored, I factored in n squared out, even though they don't all have an n squared in them, I was still able to do it. And you could just say, how do you know you're right? You could FOIL that out and you get back to the original. So this is the idea that I'm using here. Okay, so if you don't know how to do this too well, or your teacher didn't teach you this way, feel free to join the meetings and talk to me about this. This is definitely something you want to be good at. Factoring anything you want. It'll come up in the end of the semester with Taylor series, but in general, it comes up in everything. It'll come up in the comparison test. It'll come up in all kinds of things that we do in this book or in this class. So please ask me for help on this. So the reason I wanted to do that is because now, because of this, I can square root the dx squared times the square root of 1 plus dy dx squared. I'm allowed to do that, right? Because it's multiplication. So then this is going to become the square root of 1 plus dy dx squared dx, right? I was able to factor out the dx, then I was able to square it or square root it, so that leaves me with the dx on the outside. Let me write this a little bit more level. Okay. Now, we know that dy dx is just the derivative, okay? So we can rewrite this again. right? So this is now something we know that if we want to find the arc length, all we need to do is use the square root of 1 plus f prime of x quantity squared. And this leads us to our formula. So here's our formula for arc length. Oops. Now, something I want you to understand is the reason this leads us to our formula with respect to x is because, now, if you come back up here and look at this, I drew one triangle, right? But now I want to kind of embrace that idea that you learned in the shell method, or that you learned in the disc washer method, is that if I wanted, couldn't I have done this instead? Couldn't I have drawn this triangle? Oops, I can't draw. I could have drawn this triangle here. I could have drawn, you know, this triangle here. I could have drawn this triangle here. Oh, oops. This triangle here. And I could have drawn all these little triangles, right? I could have drawn all these little triangles. Instead of drawing one big one, I could have drawn a bunch of smaller ones. And each of those smaller ones would have a more accurate arc length for their little sections, right? So how many triangles could I end up drawing? Well, if you think of it conceptually, I could just keep drawing more triangles and more triangles and more triangles. And each time I add more triangles to it, I'm getting a more accurate assessment of the actual arc length versus my approximate arc length. Now, what's the only way to make it become exact? We turn to integrals, because integrals are basically the limit of the Riemann sum. So in a way we're doing, or not in a way, we're doing the Riemann sum of all these arc lengths of these triangles. So that leads us, instead of going and redoing all of that again, like you did in the disc washer method and the shell method, I'm going to just kind of say that you guys got that part. So I'm going to give you the formula for it. So L equals the integral from a to b of the square root of 1 plus f prime of x squared dx. So the big thing is with this, formula right here, is that this is basically saying you're not just drawing one triangle, you were drawing or you were approaching an infinite amount of triangles to help you calculate that arc length. And it is no longer an approximation, it is now exactly the arc length, okay? So up here, this arc length would have only been for that one triangle that I drew, okay? So for the one triangle that I drew, you would have found the arc length as an approximation, okay? But it would have been that exact length of that triangle. But now we're doing a near infinite amount of them. We're approaching an infinite amount. And that means we're able to find the exact area, okay? So this is the formula for that one. Let's look at the formula with respect to y. So we're going to say L equals, and then we have the integral from a to b of the square root of 1 plus g prime of y squared dy. And it's normally pretty obvious with these problems when you're dealing with dx or dy, they normally give you the limits of integration in terms of x's or in terms of y, okay? So this is our formula for with respect to y. Okay, so let's try an example problem, okay? So suppose I ask you to find the length of the curve x equals y cubed over 6, I believe. Yeah, let's use this one, plus 1 over 2y from y equals 1 to y equals 2, okay? So first things first, we have to find the derivative of this. So what we're going to do is we're going to say dx dy, oops, we're so used to doing dy dx, we're doing dx dy, and think of that, you know, the reason for that is look what they gave me as my limits of integration. They gave me my limits of integration as y values, so that means that I'm definitely using this with respect to y, so I'm doing g prime, okay, g prime of y instead of f prime of x, just a notation thing. So we're going to get, let's see, the derivative of y cubed over 6 would be 3y squared over 6. And I think this will be minus, because this right here is a negative exponent. So this will be minus 1 over 2y squared, right? Or 1 over, you know what, I'll write it the original way and then we'll clean it up. Minus 1/2 y to the negative 2. Because it was y to the negative 1, if we subtract 1 from the power, we'll get that. So that means this cleans up to y squared over, what, 2 minus 1 over 2y squared. Yeah, that looks good, okay? So that's our derivative. And we know that our arc length formula says that we're able to do this. We're going to integrate from 1 to 2. Oops. We're going to integrate from 1 to 2. And then we're going to find the square root of 1 plus. Now we have to do this. Y squared over 2 minus 1 over 2y squared. Okay? And then we square that. And then we do dy. All right? So let's FOIL this out. So this would end up becoming y to, oops, I believe this would become y to the 4th over 4. Sure. And then this is going to become, the middle term would become minus, I think 1/2. Yeah, when you FOIL that out, that'll become minus 1/2. And then this will become plus 1 over 4y to the 4th. Yep, that sounds good. And again, if not, you guys just come over here and do y over squared over 2 minus 1 over 2y squared, and then multiply it by another one of itself, y squared over 2 minus 1 over 2y squared, and then FOIL it. And you guys will get the same thing as me, okay? So this actually becomes from 1 to 2, the square root of y to the 4th over 4 plus 1/2 plus 1 over 4y to the 4th dy, okay? And all I did, you guys, is I took this guy right here and I added him to this guy, and that left me with 1/2. Okay, I took the 1 and the minus 1/2 and rewrote it like this. So now we're looking at this problem and we're kind of in trouble, okay? So we're kind of in trouble because U substitution won't work. We don't have a bunch of other techniques right now at this point in our math careers, so we're kind of stuck on this problem. So what you need to do is you need to think of what is causing the trouble. Why can you not integrate this, okay? Because if the square root wasn't there, then I could integrate this term by term, piece by piece. I could just integrate y to the 4th over 4 plus 1/2, integrate that one, plus 1 over 4y to the 4th. So if the square root wasn't there, this is an easy problem. But because the square root is there, that means it's a composition of functions. That means we can't really do U sub unless there's a nice clean U sub. But U sub would be what I would try first, but it won't work because the dy or the dy is just going to have too much left over for the du to account for. So what are our options? Well, this is where you try to pause the video and kind of mess with this a little bit before I tell you how to do it, okay? So hopefully you guys have unpaused the video now and you got it. But if you didn't, because the square root is the problem, I am hoping that this is a perfect square. Because if that's a perfect square, then when I factor it, it'll cancel the square root. So what I'm going to do is I'm going to try to see if this is factorable as a perfect square. So in order for a perfect square to be factorable, you square root the front and you square root the back, and you see if you would be able to build the middle. Okay, so let's see. So this will be y squared over 2 plus 1 over 2y squared. So all I did, just to reiterate, all I did was I square rooted this. Oops. I square rooted that and I square rooted that. Okay, and that's where this and this came from. Now what I'm going to do is I'm going to do a little scratch work over here to make sure that this is in fact the factors. Y squared over 2 plus 1 over 2y squared. Okay, and now let me go back here and fix this. All of this is quantity squared. I'm thinking that this is how you would factor this. I'm hoping, right? I already have done this problem a lot of times, obviously, so I know it's going to work, but you guys haven't. So I'm trying to tell you how you have to think of it. And you have to think of it by saying that I know I need to cancel that square root out, and what would cancel the square root was the square, okay? So I'm trying to work my way to that. So what I do is I say, well, if it was a perfect square and it was factorable, this is how it would be written. So now I need to FOIL this, okay? And this would become y to the 4th over 4, plus this would become, what, 1 over 4, plus this one right here would become 1 over 4. And now we do the last. That would become 1 over 4y to the 4th. So this would become y to the 4th over 4 plus 2/4, but that's really just 1/2, plus 1 over 4y to the 4th. That is the same as that. So it actually worked, right? So that means that this was factorable as a perfect square. So that means I can now do this. So we have dy. We're now going to cancel that with that. And now let's see the new problem that we have. So this is L equals from 1 to 2, y squared over 2 plus 1 over, you know what, I'm going to write it as a negative exponent so it's easier to work with. And I'll write this as 1/2 y squared dy. Okay, so now this is a nice easy problem to factor, right? Or not to factor, to integrate. So this would become 1/2 y cubed, let me write this better, y cubed over 3 plus 1/2 y to the -1 over -1 from 1 to 2. So this would become 1 over, you know what, we'll just leave the 1/2 on the outside. This will become 8 over 3 minus 1 over 4 minus, let's plug the 1 in there, 1 over 3 minus 1 over 2. So all I'm doing is plugging this in. So here you must show on your exam. So this step, a lot of people skip. A lot of people skip this step where they write it out. You have to show me that you know how to write out f of b. So this is big F of b minus big F of a. Okay, the antiderivative evaluated at 1 and 2 or 2 and 1. So you must show on your exam. You must show this step. Now you can plug this into your calculator now and get the answer. Okay, so that's all I'm going to do. I'm going to take my calculator and I'm just going to do 8 divided by 3 minus 1 divided by 4. Hopefully I didn't make any mistakes. That'll be 29 over 12 minus 1 divided by 3 plus 1 divided by 2. And that's 31 over 12 times 1 divided by 2. And I get 31 over 24. And I think I made a mistake. Oh, did I make a mistake? Minus 1/4. I think I made a little error in here somewhere. Let me see. Let me clean this up a little bit, you guys. I think I made a little calculation error in here. That should be 8 over 3 minus, oh, right here, minus 1 over 2. Yeah, please fix that right there in your notes. That should be a 1 over 2. Now let's see if that works. So we're going to do 8 divided by 3 minus 1 divided by 2. Now we're going to do minus 1 divided by 3 plus 1 divided by 2. Now we're going to multiply that by 1 divided by 2. That doesn't seem right. Let's see here. Let me write this out, guys. I must have made a silly mistake in here, and I'm trying to fix it. All right, so that would be 1 over 6 y cubed minus 1 over 2y from 1 to 2. Okay, so this would be 2 times 2 times 2, so this would be 8 over 6 minus, oh, let's see here. Oh, that's 1 over 4 minus, now we plug 1 in. This would be 1 over 6 minus 1 over 2. And let's see if that works. So this will be 4 over 3 minus 1/4 minus 1 over 6 minus 1/2. I'm just going to plug this on my calculator. Hopefully it works this time. 4 divided by 3 minus 1 divided by 4 minus 1 divided by 6 plus 1 divided by 2. There we go. Yeah, that's it. 17 over 12. So I must have made some calculation error in there. I had the right problem, but when I plugged it in. So you must show f of b minus f of a on your exam. Okay. The reason for this is you could literally take this problem right here and I could plug that into my calculator right from there, not even integrating, not doing anything. And I could plug that into my calculator and hit enter and it would give me the answer. So that's not cheating, but that's definitely not showing me that you know how to integrate, okay? So you're just showing me you know how to hit enter on your calculator, okay? There are some homework problems that actually ask you to use technology because the problem cannot be integrated. So just keep that in mind. There are certain problems in the homework that you cannot integrate by hand. They just ask you to set it up and then use your calculator to hit enter, okay? If you guys are having trouble using your calculator to do that, please, come to a meeting and talk to me about it and I can go over that with you. Okay, so L is 17 over 12. Okay, so let's see here. How much more time do I want to spend on this? We could do another one. So let's do another example. Okay, so find the length of the curve y equals 4x to the 3/2 power between x equals 0 and x equals 1. Let's go with 0 and 1. Okay. So first things first is we need to find f prime or y prime, whatever you want to say. Let's call it y prime. And that means that it's 4 times take the power, put it in front, rewrite the inside, reduce the power by 1, right? So I just did 4 times 3 over 2, reduce 3/2 by 2 over 2, which is 1/2, so we get this. So then this cleans up a little bit to cancel. So we got 6x to the 1/2, right? So now what we're going to do is we're going to say L equals the integral from 0 to 1 of the square root of 1 plus 6x to the 1/2 quantity squared dx. Well, this seems like a little bit nicer problem to me. This will become the integral from 0 to 1 of the square root of 1 plus 36 x dx, okay? So then this is, another little u substitution. This time u sub does work. So then du equals 36 dx, divide both sides by 36, right? These cancel. So then we're left with du over 36 is worth a dx. So now I can plug this in. Let me put must show on exam. I'm not going to remember every single thing to write this next to, but these are the things that I have seen people skip that you have to show me. You must show me your u substitution. Takes an extra 30 seconds, so that should not stop you from finishing a problem. Oops, sorry about that. So now we have, let's come over here now. L equals the integral of the square root, or u to the 1 over 2, du, and I'm going to put the 1 over 36 in front, right? Because this du over 36, the 1 over 36 is just a constant. I can move it to the front. So now we have L equals 1 over 36. Also, remember, we don't know our limits of integration. For u, you have two choices. You can either stick to 0 and 1, but then that means you must plug back in, you absolutely must plug back in whatever you said u was. If you want to stick with u, then you change your limits of integration over here. So right here, it says, and again, this is something you should have learned in Calc 1, in the beginning of Calc 1. So what you do is you say u equals to this. I'm just doing this for a review for some of you that maybe didn't like the way it was taught or never learned it this way. You can just say, you know, do a little scratch work. U equals, you know, I'll write it right below over here. U equals 1 plus, now x is worth 0, so for x equal to 0, this is going to be 1 plus 0, so u equals 1. And then for x equal to 1, we're going to say u equals 1 plus 36 times 1, so then u equals 37. Okay, so then our limits of integration are technically 1 to 37 if we're doing, if we're going to stick to u. If you don't like this way, then, you know, figure out what the integral will be and then, you know, plug back in the original. Okay, so now this will become, let's see here, u to the 3/2 over 3/2 from 1 to 37 because I changed my limits of integration. So now we have, so this will be 2/3. So this will be 2 over 36 times 3 times u to the 3/2 from 1 to 37. And I'm just doing this to save myself some time. So this will become, what is that? 54, 1 over 54 times 37 to the 3/2 power minus 1 to the 3/2 power, which will just be 1 over 54 times 37 to the 3/2 minus 1. And this would be an acceptable answer. If they ask you for a decimal approximation, you would do this. So hopefully I didn't make any silly mistakes again, and this should be correct. If you guys don't like this method, okay, let's say you don't want to do this in terms of changing u, then you would have just had L equals 1 over 36, the integral of u to the 1/2 du. That would have equaled 1 over 36 u to the 3/2 divided by 3/2 from 0 to 1, but you can't use those yet because those are for x's. So then we have to do we have to do 1 over 36. You know, I can take that 2/3 out just like before, so this will be 1 over 54. And then this will become, we said that u was worth 1 plus 36x. So this will be 1 plus 36x to the 3/2 power from 0 to 1. Now we can plug that in and we get 1 over 54. And this will become 1 plus 36 times 1 will be 37 to the 3/2 power minus 1 plus 0 to the 3/2 power. And I hope you guys can see it's going to end up being the same answer, which is identical to what we have above. Okay, so this is 2 problems that you can use for arc length. This should get you started on the homework. Remember, some of the problems will ask you to use your technology, like meaning your calculator, to integrate it. That means they just want you to plug it in and get a decimal approximation. I don't know if I'll do one of those on the exam. More than likely, I'll probably give you guys one like this one or the one above, or maybe even something with sine or cosine like in the homework. But again, not every integral can be integrated by you at this time. So sometimes if it says use technology, they're specifically telling you that you can't integrate this problem. You have to use your calculator to approximate the integral. Okay, you guys, that'll do it for this video. Thanks for watching.